Hello everyone, my name is Emily Larson and I will be walking you all through the Aldol reaction. The first thing you're going to need to know is what an alpha carbon is and what an alpha hydrogen is. So if we have a ketone with a carbonyl group, the carbons that are one carbon away from the carbon in the carbonyl group are going to be alpha carbons. These carbons have hydrogens attached to them and we call them alpha hydrogens. Now what makes them so special? Well, these alpha hydrogens are acidic. They have a pKa of about 20. This is because of their proximity to the carbonyl group. Now if we compare them to an alkane group where there is no oxygen nearby, we'll see that these hydrogens on the carbons have a pKa of around 50 to 55. So looking back at the pKa of these alpha hydrogens, they are very acidic. And what do we know about acidic things? Is that bases love acidic things, so bases love these alpha hydrogens. So this will lead us to the next thing you need for an Aldol reaction, and that is the formation of an enolate. So for this, we're going to look at the most common enolate formation, which is base catalyzed. So we will start with a ketone with a phenyl group on one side, so we can only use one alpha carbon, and the base will deprotonate that alpha carbon, leaving a negative charge on the carbon. This structure will undergo resonance, and these two resonance forms are the enolate needed for the Aldol reaction. The resonance structure with the negative on the carbon is the carbanion, and the negative on the oxygen is the oxoanion. So these enolates are very stable, which means they're going to be amazing carbon nucleophiles, which is super essential for the Aldol reaction, which is our next section. Alright, for the mechanism, we're going to do a pretty basic reaction mechanism. So the first thing you're going to do is you're going to want an enolate. So you're going to take one of those enolates. We're going to use the carbanion. You could use the oxoanion if you want, but for this we're just going to use the carbanion. And we're going to react it with itself, so a ketone. The negatively charged carbon is a nucleophile, and the carbon attached to the carbonyl is an electrophile. So as we know, the nucleophile will attack the electrophile. Same thing is going to happen here. And that double bond will flip up to the oxygen. So we'll form a new bond between that enolate, which was shown with the black box, and the ketone, which is shown with the orange box. So all that happened is a new bond between that negatively charged carbon and the carbon of the carbonyl. So next step, we'll just take that conjugate base and protonate that negatively charged oxygen. So now we have our final aldol product. And the way you can always tell that it's an aldol product is you have that aldehyde group and an hydroxyl group, so an alcohol, so aldol. And also it will always be a beta hydroxyl carbonyl. This means that if we can find our carbonyl group and alpha, then beta carbons away from that carbonyl group, there will be an alcohol group on that carbon. We could stop there with the aldol product, but we can go one more step with aldol condensation for our section 4. Alright, so we will start with our aldol product, so it is that beta hydroxyl carbonyl, and we will react it with some base. We started with base, so we'll do base again. So that base will deprotonate the alpha carbon again, and we will end up with a negatively charged carbon on that alpha carbon. Alright, so next those electrons on that alpha carbon will flip down to the new bond we formed during the aldol condensation, and that hydroxyl group will pop off and result. So this time we'll get a double bond forming where that new bond had been, and that's going to be an alpha beta unsaturated aldehyde. So every single aldol condensation product will have this alpha beta unsaturated aldehyde. Alright, so we can also do this reaction with acid. So we're going to look at this hydroxyl group. It'll grab a hydrogen from the acid, and then it'll form a really good leaving group, OH2, so that's going to pop right off. So then our next product, we're going to have a carbocation, and we're going to want to look at that alpha hydrogen again. And so the conjugate base of the acid will grab the hydrogen, and those electrons will flip down and form a double bond where that new bond had formed during aldol condensation. So this last step might look really similar to the elimination reactions we learned in Orgo 1, but it's not quite that elimination. It's called E1CB, and it's specific to this aldol condensation reaction. Alright, so that is all we have to go over for the aldol condensation and aldol reaction. Just as a summary, for these aldol reactions, it depends on those alpha hydrogens and them being acidic. They're acidic because they are an alpha position away from the carbonyl carbon. If we add a base to these ketones or aldehydes with these alpha carbons, then we will form an enolate, and this enolate has two forms because of resonance. It has the carboanion form and the oxoanion form. For an aldol reaction, you're going to want one of those enolate forms. You can use either one. For this, I'm just showing the carboanion form, and you're going to react it with the original molecule. So for this, we're reacting it with the original aldehyde. And we're going to add to that either acid or base. And I'm not showing the mechanism, but this will bring us our aldol product. So we're going to form a bond between the alpha carbon on the enolate and the carbonyl carbon on the aldehyde or ketone. And this will always form a beta hydroxyl carbonyl on that carbon that is beta positions away from the carbonyl carbon. If we add base or acid again, we're going to have aldol condensation occur. This results in the original new bond from the aldol product being a double bond, and this will always be an alpha beta unsaturated carbonyl. And remember that this was formed by an elimination-like reaction called E1CB. Right, so that's our summary for the aldol reaction and aldol condensation. Now on to some tips and tricks for these reactions. First, make sure to look out for those alpha hydrogens. There might be alpha hydrogens present on both sides of the carbonyl group. This is not ideal, and I'll show you this later. Just always make sure to take a look at your molecule before you begin the reaction mechanism to make sure there aren't different enolates possible. As you can see here, when there's a phenyl group on one side or it's an aldehyde, you're not going to have this issue, but this is something you want to make sure to look out for. Here's an example of what happens when we have two different enolates possible. First, we can get an enolate on the right side and an enolate on the left side, so it just depends on where that negative charge is. So following these reactions for the aldol reaction, I'm doing just a abbreviated version to show the difference between the two enolate positions. So we are going to get two different molecules, and this is not ideal because this will result in a mixture instead of a pure solution, so this is definitely not favorable. So moving on to our next tip, this is a trick for aldol condensation and figuring out what the product is. All right, so for this, you can use this on quizzes or exams. If they're not asking for the mechanism and they just want the product, this is a really quick way to get the product of an aldol condensation reaction. So you're going to start with that aldehyde and the enolate, and what you're going to do is you're going to take that aldehyde and the carbonyl group, and you're going to position it right underneath the negatively charged carbon. So then imagine drawing a line from that carbonyl carbon right to the negatively charged carbon. That is where the new bond is going to form for the aldol reaction product. That is also where the aldol condensation double bond is going to come from. So instead of going through aldol reaction, aldol condensation mechanism, just take that aldehyde, put it right underneath the negatively charged carbon and draw a double bond there, and that will be your aldol condensation product. Here we're using a ketone group and just an aldehyde enolate, so two different molecules. but you can see that it works the same way. We're taking that oxygen, putting it right underneath the negatively charged carbon, and it's going to form the double bond right where that new bond would form. Alright, so that concludes this video on aldol reaction and the aldol condensation. Just as a disclaimer, I have not gone over everything there is to know about the aldol reaction and aldol condensation, so there are definitely some more things to go over for that. But this is a super important reaction in organic chemistry, so it's definitely good that you watched another video on it, and thank you so much for watching, and good luck!